Hi, today I will speak about call stack, and in this playlist we'll speak about 33 concepts every JavaScript developer should know. The JavaScript ecosystem has become more complicated than ever and will continue to become more. The tooling that is required to build a modern web app is overwhelming, with Webpack, Babel, ESLint, Mocha, Karma, Grunt. JavaScript is a single-threaded, single-concurrent language, meaning it can handle one task at a time or a piece of code at a time. It has a single call stack which, along with other parts like heap, queue, constitutes the JavaScript concurrency model, implemented inside of V8. Let us first go through each of these terminologies. One call stack: it's a data structure which records the function calls, basically where in the program we are. If we call a function to execute, we push something onto the stack, and when we return from a function, we pop off the top of the stack. As we run the above file, we first look for the main function where all the execution will start. In the above, it starts from console.log bar6, which is pushed onto the stack. Next frame on top of it is the function bar with its arguments, which in turn calls function foo, which is again pushed onto the top of stack, and it returns immediately and so is popped out of stack. Similarly, bar is then popped out, and finally console statement is popped out, printing the output. All this happens in Jiffy, in MS, one at a time. You all must have seen the long red error stack trace sometimes in our browser console. That basically indicates the current state of the call stack and where in the function it failed in a top-to-bottom manner, just like stack. See image below. Sometimes, we get into an infinite loop as we call a function multiple times recursively, and as for Chrome browser, there is a limit on the size of the stack, which is 16,000 frames. More than that, it will just kill things for you and throw max stack error reached. Event loop. Basically, when we evaluate the performance of our JS code, so a function in a stack makes it slow or fast, console.log will be fast, but performing iteration with for or while over thousands or millions of line items will be slower, and will keep the stack occupied or blocked. This is termed as blocking script, which you have read or heard about in web page speed insights. Network requests can be slow, the image requests can be slow, but thankfully the server requests can be done through AJAX, an asynchronous function. If suppose these network requests are made through synchronous functions, then what would happen? The network requests are sent to some server, which is basically another computer/machine somewhere. Now, computers can be slow sending back the response. In the meantime, if I click some CTA button, or some other rendering needs to be done, nothing will happen as the stack is blocked. In multi-threaded language like Ruby, it can be handled, but in single-threaded language like JavaScript, this is not possible unless function inside the stack returns a value. The web page will hell breaks loose as the browser can't do anything. This is not ideal if we want fluid UI for the end user. How do we handle this? The easiest solution is by using asynchronous callbacks, which means that we run some part of code and give it a callback function, which will execute later. We all must have encountered asynchronous callbacks like any AJAX request using $.get, set timeout, set interval, promises, etc. Node is all about asynchronous function execution. All these async callbacks doesn't run immediately and are going to run some time later, so can't be pushed immediately inside the stack, unlike synchronous functions like console.log, mathematical operations. Where the hell then they go and how they are handled? If we see a network request in action in JavaScript like in above code, the request function is executed, passing an anonymous function in onReadyState change event as a callback to execute when a response is available sometime in the future. Script call done is immediately output to the console. Sometime in the future, the response comes back and our callback is executed, outputting its body to the console. The decoupling of the caller from the response allows for the JavaScript runtime to do other things while waiting for your asynchronous operation to complete and their callbacks to fire. This is where browser APIs kicks in and call its APIs, which are basically threads created by browser implemented in C++ to handle async events like DOM events, HTTP request, set timeout, etc. After knowing this, in Angular 2, zones are used, which monkey patches these APIs to cause runtime change detection, which I can get a picture now, how they were able to achieve it. Browser web APIs threads created by browser implemented in C++ to handle async events like DOM events, HTTP request, set timeout, etc. Now these web API can't themselves put the execution code onto the stack. If it did, then it would randomly appear in the middle of your code. The message callback queue discussed above shows the way. Any of the web API pushes the callback onto this queue when it's done executing. The event loop now is responsible for the execution of these callbacks in the queue and pushing it in the stack, when it is empty. Event loop basic job is to look both at the stack and the task queue, pushing the first thing on the queue to the stack when its C stack is empty. Each message or callback is processed completely before any other message is processed. In web browsers, messages are added anytime an event occurs and there is an event listener attached to it. If there is no listener, the event is lost. So a click on an element with a click event handler will add a message, likewise with any other event. The calling of this callback function serves as the initial frame in the call stack, and due to JavaScript being single-threaded, further message polling and processing is halted pending the return of all calls on the stack. Subsequent, synchronous, function calls add new call frames to the stack. In the end, I want to thank you for watching. See you in next video. Please like and subscribe. Good luck.